Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. A few weeks ago, I had a chance to attend the TensorFlow Developer Summit on the Google Cloud campus in Sunnyvale, California. I had a great time at the summit, meeting a bunch of TWiML listeners and friends of the show, and learning about all the new features released as part of the TensorFlow 2.0 alpha. This week on the show, we'll be bringing you a series of conversations from the event, which will be kicking off with today's interview with Paige Bailey, a TensorFlow developer advocate at Google. Paige and I sat down to talk through the latest TensorFlow updates, and we cover a ton of ground, including the evolution of the TensorFlow APIs, and the role of eager mode, tf.curious, and tf.function, the introduction of TensorFlow for Swift and its inclusion in the new fast.ai course, new updates to TFX or TensorFlow Extended, Google's end-to-end machine learning platform, and the emphasis on community collaboration with TensorFlow 2.0, and a bunch more. Now, Dev Summit attendees received an awesome gift box from Google that included some really fun toys that will appeal to the hackers and builders in our audience, including the new Coral Edge TPU device and the SparkFun Edge development board powered by TensorFlow. If you're a geek like me and get excited about toys like this, I'm excited to share that we've got our hands on a few of these for you, our dedicated listeners. To enter to win one, just visit twimlai.com/TF giveaway and let us know what you would do with this kit if you got your hands on it. Of course, we'd like to send a huge thanks to the TensorFlow team for helping us bring you this podcast series and giveaway. With all the great announcements coming out of the TensorFlow Dev Summit, including the 2.0 Alpha, you should definitely check out the latest and greatest over at tensorflow.org, where you can also download and start building with the framework. And now, on to the show. All right, everyone, I am here with Paige Bailey. Paige is a developer advocate for TensorFlow with Google, and we're here at the TensorFlow Developer Summit. Paige, welcome to This Week in Machine Learning and AI.
Excellent. I'm delighted to be here.
I am excited to have you on the show and looking forward to diving into all that's new and interesting with TensorFlow. But before we do that, a little about your background. How did you get started working in all this stuff?
Yeah, so I got started working in machine learning and data science before data science was really a term, I guess. My background in undergrad was very geophysics, applied mathish. I did research in planetary science, doing sort of data analysis on large amounts of data from NASA equipment. So I got to work at places like the Laboratory for Atmospheric and Space Physics and Southwest Research Institute doing lunar ultraviolet research. And that today, doing statistical analysis on multivariate data would be called data science. But back then it was just called research. So that was when the bug first started. And then I started doing machine learning for work when I worked at Chevron for predictive modeling in the oil and gas industry. So I guess in terms of data sciencey things, I've been doing it for about 10 years. For machine learning, about 5 to 6.
Did you jump from Chevron to Google?
No. So that was an interesting sort of career progression, I guess. I had done planetary science research as an undergrad for my first 2 internships, and then my third was with Chevron.
Okay.
And they had me on a really cool project. I got to create a database and do some scripting, some geospatial analysis using Python. And after it, they said, "Hey, do you want to come work for us?" And that sounded like a cool job opportunity, especially since they were offering to pay for grad school. And I went to go work there for about 5 years. And after Chevron, it was time to kind of leave and to explore new opportunities. And that was Microsoft. So I worked for Microsoft doing machine learning developer advocacy, and then as a senior software engineer in the office of the Azure CTO.
For those that aren't familiar, what exactly is a developer advocate and how does that translate into how you spend your day-to-day?
Absolutely. So that is a great question. And developer advocacy means different things to different companies. Here at Google, developer advocacy is very focused on improving the experience for our end users and for basically anybody who would go about using our tool. And that can include everything from improving documentation to user experience research, to building tutorials and quick starts, to creating curriculum materials like the Udacity and Deep Learning AI courses that we just released, to also engaging with the community via social media, but also through things like special interest groups and making sure that if there is a problem with the tool, it's surfaced, fed back to the engineering team, and we can build a plan to resolve whatever that issue happens to be. So if anything is frustrating, so if maybe a higher level API isn't intuitive, it might require making a pull request and resolving that, or say we're missing a symbol in our documentation, then making a pull request and fixing that in the docs. So it's really a variety of things, but as I mentioned, it's all very focused on communication, improving the developer experience, education, and also very much engineering tasks. So,
Okay.
and if you're a person who enjoys all of the above, then maybe developer advocacy is right for you.
Awesome. So there was a bunch of interesting TensorFlow news yesterday.
Yes, there was so much. It felt like a fire hose almost, and that's coming from someone who knew it was all about to happen. So many new products. Yep.
Yeah, so I'm really interested in kind of digging into them. One of the things I've mentioned this to a couple of times, maybe yesterday. One of the things that's been a little bit difficult for me to parse as an outsider is like, what exactly is new in all of these things that are kind of new? Like eager mode was highlighted very extensively yesterday, but that was announced last year. There were other things that I'm like, I know I've seen this before. There was a paper that was a couple of years ago, so for me, probably the best thing to do is to have you kind of walk through from your perspective, what were the highlights, and what was new, and then we can kind of dig in from there.
Right. So it is difficult to kind of place what's actually new and then what's just been kind of bundled and packaged, right? So the biggest announcement yesterday by far was the alpha release of TensorFlow 2.0. And TensorFlow 2.0 is a new version of TensorFlow focused on developer productivity, ease of use, Keras as the recommended higher level API, and eager execution by default, which enables you to do things like better debugging, but also the Pythonic experience that you, especially folks coming from scikit-learn and the data science community, would expect. So TensorFlow 2.0 is I mentioned it's eager execution by default, and you're correct in that eager execution was announced last year. But in order to enable it, you had to do something called like tf.enable eager execution at the top of your script. So you had to kind of specify that at the beginning, and you had the option of sticking in graph mode if you didn't enable eager execution. TF 2.0 is eager by default.
Okay.
Which means that you don't have to have that line, but you're thrown directly into this experience where you don't have to create a static graph, you don't have to have sessions, you don't have to create the thing before you can interact with it, before you can actually start using it. It feels much more Pythonic. So that's kind of a new thing in that eager execution by default. Another very, very new thing is that TensorFlow 2.0 was created entirely in collaboration with the community through the RFC process. So every change that was made to the API had to be proposed by an engineer or proposed by someone, endorsed by the entire community, discussed, and before it was incorporated. So if you have any curiosity about these RFCs, you can go and take a look at it on github.com/tensorflow/community. We have a list of all of them. And if you care about details, they're all important. We also have a community of special interest groups, everything from TensorBoard, which is a visualization tool, to Build, which is sort of building TensorFlow for various Linux distributions, and then also with NVIDIA graphics card drivers and the like. We have a special interest group for testing. So if you're trying out TensorFlow 2.0 and you're running into snags, or if you need migration support, there's that option for you as well. And then others around networking and data ingestion and lots of different ways to get involved. And really, as I mentioned, the focus on TF 2.0 is community, sort of building something that people would love to use, as opposed to the first TensorFlow release, which kind of felt like, hey, here's some code, like go forth and prosper, and not exactly the most straightforward sort of code. So, so that's the general idea.
A lot of the kind of top line takeaways around kind of APIs and developer experience. The eager by default, you can kind of think of that as, okay, so there's one line of code less that I have to write. But is it deeper than that in terms of the underlying architecture and the way that that TensorFlow supports that?
That's a great question, and absolutely. So Carmel, during the keynote yesterday, she had this great slide where, so if you're a Keras developer, if you have experience using tf.keras, you can create a neural network with about 10 lines of code, and it's very straightforward. It's intuitive. It's easy to understand. And again, feels very Pythonic. She showed a slide saying, here's what your model would look like if you were using TensorFlow like 113 or TensorFlow 112 or whatever version. And it's 10 lines of Keras. And then she said, and here's what it would look like in TensorFlow 2.0. And it's the same code, the same code expressed both ways. But the reality is that TF 2.0 is doing a lot of things under the hood to improve model performance, and to take that same Keras code and make it scalable in a way that it wasn't experienced before. So even though the code looks exactly the same, there are a lot of optimizations under the hood that makes it a bit more performant, especially with distributed architecture. So with distribution strategies.
One of the things that was presented yesterday was there's a fair amount of detail that was gone into around tf.function. Is that totally new?
Yeah, tf.function is new. tf.function is basically a way for you to take any sort of Python function, wrap it and define it as a core TensorFlow operation. So you could have anything from adding two numbers, right? So you could have a function that would take, you would define something that would add A and B. And if you preface it with an at TF function, it would define it as a core TensorFlow operation that then you could then use in your graph. That is pretty new. People have had a lot of positive feedback about autograph and TF function both when using TensorFlow 2.0. And it makes it a lot easier to take things that traditionally would have been very difficult to do with static computation, static graphs, and sort of use them in a friendly, dynamic way.
Okay. And what is autograph?
Autograph helps you write complicated graph code using normal Python. So it automatically transforms your code into the equivalent TensorFlow graph code, and it supports a lot of the Python language. So that's a kind of one-liner explanation of autograph.
2.0 introduces some significant changes to the API, but that's not the only kind of developer experience kind of announcement. One of the ones that's gotten a lot of conversation going is around the Swift for TensorFlow.
Yes.
I'm curious what your thoughts. Do you know Swift? Have you played with that at all?
So I have fiddled with it, but only since I got to Google. I hadn't really experimented with Swift before. Well, I get to sit next to Chris Latner, which is Chris Latner and Brennan and the entire Swift team. So that's kind of rad. And the idea behind Swift for TensorFlow is that if you're a Python developer, Python is great in terms of user experience. As a user interface, as a programming language, It's a great way to build out products, but it also has a lot of limitations and drawbacks. So, for example, gradient tape is something that causes a great deal of frustration whenever you're using TensorFlow.
Gradient tape?
Gradient tape.
What is that?
It's how you deal with variables as you're creating your graph. And so as a Python developer, it's often very frustrating to try to manage all of these different aspects. But with a lower level tool like Swift, a language that's a little bit closer to C++, you get afforded a great many more a lot more control over what you're creating. And that's kind of the idea. And I think that's what captured the imagination of Jeremy Howard. So I'm sure you saw that announcement as well. He's using Swift for TensorFlow for his latest iteration of the FastAI curriculum, which we're all very excited about. And I'm very curious to see how that progresses. Another really cool thing about Swift Swift for TensorFlow rather, is that you can use Python within Swift, just with import Python. And there's a great demonstration from Brennan and from Chris yesterday where you could, create something like a plot of performance or accuracy over time with matplotlib, just as simply as you would with Python, except all you have to do is preface it with let. For your variables. So I think Swift for TensorFlow is a really interesting space. They're still very new. So they're still developing their story and they're still developing the product. But I'm curious to see how it progresses this next year. And they certainly have a vibrant community. Like if you have any, I mentioned the special interest groups a little bit before, but they also have these really active mailing lists where people are asking questions and sharing products that they've created and sort of ideas that they have about changing designs of API and technical things. And the Swift for TensorFlow user group and mailing list is consistently one of the most active. So if you have curiosity about it, absolutely join and send your questions to swift@tensorflow.org.
Awesome. Yeah, people keep asking me like what I think about it. I'm like, I don't know. I've never seen Swift outside of a slide on, at the
Apple,
presentation
right?
yesterday.
It's very, when I first, because it was announced last year, Swift for TensorFlow, but in a very sort of low key way, right?
Okay. I missed that.
Yeah, like it was a presentation. It was also the best non-leak of TensorFlow history. I think like nobody anticipated that it was coming, but so it was announced last year. And all of the progress that you've seen since has been made since that initial announcement. But yeah, like usually you would think Swift and think, iOS or something.
That's exactly what I think.
Yeah.
But yeah, I tell people I'm kind of excited about it because Jeremy's excited about it. Part 2 of the new course is starting up soon, and it sounds like he and Chris will be collaborating on a couple of lessons in that course to kind of highlight.
Yeah.
Not just kind of highlight the Swift for TensorFlow, but also this is maybe a little bit of kind of inside baseball or whatever, but like the way that the way that he builds the courses is basically by building out the framework, right? And that becomes the process of building out the framework becomes the course.
Yep.
And so it sounds like what he and Chris will be doing in this course is like starting to build out the Fast.ai Swift version as kind of part of this course. It's really fascinating kind of approach for multiple reasons. I took a look at his blog post about kind of why he was so excited about Swift, and one of the reasons that he's real plain about is like this is the ground floor opportunity. Like Swift, TensorFlow or rather Python, there are all of these challenges associated with like the barrier between Python and C when you have to get really deep and not being able to debug all the way through and not be able to trace variables all the way through, that kind of thing. and needing to kind of shim out underneath Python to get performance. And one of the reasons why he's excited about Swift is because it is high performance. Yeah. And, to the extent that over time, kind of the entire stack gets built in a high performance language, you don't have these barriers that you have to figure out.
Absolutely. It's a fascinating space. And also, one of the things that shocked me the most, I guess, about Swift was how intuitive it was to understand as a language. Like if you look at the Swift code used to generate a neural network, it feels very similar to Keras. Like it's not because I took some C++ classes in college, and I am not a fan, and will not be shy about saying that. Like I love the idea of it conceptually as a language, but it's something that's very it doesn't feel natural for me to use. Mm-hmm. Swift feels a great deal more natural. And one of the challenges I think that they're going to face is that Swift, as you mentioned, hasn't traditionally been a data science-y language.
Right.
So they don't have all of the vast libraries of tools that Python has. So things like matplotlib and scikit-learn for traditional machine learning tasks and the like. But it's really interesting in that so we're doing Google Summer of Code for the very first time this year. Mm-hmm. And 5 of our proposed projects are Swift for TensorFlow related. Mm-hmm.
Summer of Code, for those that don't know, is a program where open source projects can get matched with like college students or students in general, maybe, and get some funding to pay them to work on the project.
Absolutely. So the Google Summer of Code, it's one of my favorite things about Google. And it was also when I applied for it a long time ago, when I was still doing the grad school thing, and I applied to a project called AIMA, and got a response back from Peter Norvig, who was apparently the person who was sponsoring the project, and that was my first email from a Googler, and it was Peter Norvig. So
wow.
It was amazing. But it's so enchanting in that open source projects can apply to be part of this GSOC program. If they're selected, they can have a partnership of mentors who are directly working on the project and students. The mentors work collaboratively with the students. Doesn't matter where they're located. They're certainly encouraged to be remote. And the students are kind of guided through making their first substantial open source contribution, and also paid for it, which, as a student, that's kind of like a dream come true, right? Like you get to work on open source, you get to be paid, and potentially you get to be mentored by, like in the Swift for TensorFlow case, like you would be mentored by Chris Latner, or the AIMA case, you would be mentored by Peter Norvig, or for the rest of our project opportunities, right? We've got Autograph and TF Function and sort of TensorBoard and TensorFlow datasets. You're mentored directly by the engineers who've created those products. Mm-hmm. So at least in TensorFlow's case and in the other projects that are sponsored, it's really a phenomenal opportunity, and I'm excited to see what the GSOC students build out for Swift for TensorFlow.
Mm-hmm.
Yeah.
Interesting. Mm-hmm. You mentioned something earlier that kind of tied to a question that I had in kind of seeing the Swift for TensorFlow announcement. How would a Swift for TensorFlow kind of play or not play with a Keras?
Yes. So Swift for TensorFlow, like you can use Keras within it. But for the most part, it's
like you can use any Python within Swift.
Yes, but it's recommended that you would program using Swift. But again, the Swift syntax looks very, very similar to Keras syntax. Mm-hmm. And we can, if folks are interested, we can share some of the Colab notebooks that like links to it that were shared yesterday. Right? I would love to see that. And another really cool thing about Swift for TensorFlow is that it works in Jupyter notebooks. It works in Google Colab. So really the notebook experience, if you're a data scientist, feels very familiar as well.
One of the big kind of announcements, in addition to kind of the under the cover stuff, was kind of a rationalization of the APIs. It sounds like it's more than just, hey, Keras is the default, and more than even, I don't know the right way to ask this, but
we're getting organized. Is
that what it is?
I think so, or at least that's what it feels like. So the original, I started using TensorFlow like not for real substantial work, but just for personal projects and like prototyping things in 2015 when it was released. And it was, oh man, like it was not fun. Like it was not good at all. Like TensorFlow, the original version, you had to write so much boilerplate in order to get something to work. And then since the initial release, it had grown just sort of exponentially. We had this module called contrib, TF-contrib, that was kind of a generalized catch-all for things that folks wanted to add. So if you were a grad student and you had created, a collection of loss functions, you would add those in contrib. Or we had tf.contrib.gan, which was really sort of beloved, GAN creation tooling for like a straightforward path to creating GANs using TensorFlow, and we'll still have it, just migrated to its own repo. But the sad reality of Contrib was that none of those contributions had a support plan. None of them had a defined owner, so like a proxy maintainer. And a lot of them maybe functioned in an earlier version of TensorFlow, but failed to work later. And there was no clear way to understand what worked, what didn't, what was a duplicate, and like how would you migrate from like a symbol to the core API. So that really wasn't defined. We also had a lot of mathematical operations and sort of more traditional statistics capabilities that were in various places in the API, but not really kind of structured and grouped together. And it was, gosh, I don't want to count how many symbols there were, but there were certainly thousands. There were thousands of symbols without any clear structure or consistent naming conventions, and a lot of duplication and a lot of sort of things that kind of failed to work together nicely. Now we've taken a more modularized approach. Mm-hmm. So all of the statistics and mathematical capabilities have been kind of bracketed off and turned into something called TF probability. Mm-hmm. So if you don't want to use all of the things in TensorFlow, like you don't really care about Keras, or you don't care about some other portion of the API, you can just use TF probability, and you can download it as a pip package, or estimators. You can just download estimators. So all of these things, we've removed duplication. We've kind of taken all of the symbols that were just kind of, dispersed to the winds and grouped them together in a way that seems more logical, and also applied a lot of sort of well thought out renames to make things more consistent and to make the sort of calls feel more intuitive. But that's kind of the idea, is that instead of one monolithic application that you have to download in its entirety in order to use a single bit of functionality, you just take the pieces that fit for you and your organization. And that helps a lot with the build and deployment process as well.
I definitely saw that in the discussion yesterday. And one of the analogies that kind of popped up in my head is like Hadoop, and not all the negative associations with Hadoop, but like people think of Hadoop as, they think of it as this one thing, MapReduce, right? When really it was like a storage system and MapReduce and like this whole ecosystem
all
of
the Apache products,
Apache stuff, right? And TensorFlow, like I think we're transitioning from a point where you would think of TensorFlow as this monolithic thing to like you got an ecosystem, right? With the probability stuff, which we can talk maybe a little bit more about, the TFX stuff, which I'm really excited about, which is almost its own ecosystem.
Yeah.
So that, I think that's an interesting kind of transition, and one that, it's kind of there's a natural point in a large open source project where you start to see that kind of thing happen.
Yeah. And it's really interesting too, at least from a developer advocacy perspective, to see the different communities that build up for each one of those tools. So, for example, we mentioned Swift for TensorFlow, and usually the folks who gravitate towards that camp are very interested in things like algorithmic fusion. They're very interested in compilers and sort of performance. And then you have folks in the TensorFlow JS community that are so TensorFlow JS is JavaScript in the browser. That are very focused on creating these sort of artistic experiences. Often, like you would have code pens to do neural drum machines, or you would have really interesting sort of like puppy ears placed on people's heads that would follow you around as you look in your phone camera or your browser, or even things like sort of in a more product centric way, like if you're a developer who wanted to include a text box in your application, automatically including something like sentiment analysis within it. So as a person is typing, it would be like, hey man, your tone's kind of negative there. Maybe you should make it a little bit happier, or maybe you should be a little bit like change this word to be this other word, and that should be fine. So those sorts of tools. And then TensorFlow Core, you get a lot of academic researchers, sure, but you also get businesses who are really interested in productizing machine learning and deep learning. And then they also are interested in TFX. And yeah, it's really cool to see.
Mm-hmm. Yeah. Well, let's maybe talk a little bit about TFX.
Yeah.
That was one of the things that I was most excited about. Mm-hmm. TFX is TensorFlow Extended.
Yes. And there's a workshop for it today as well.
And there's a workshop for it today that I will be popping in on. Mm-hmm. I'm excited about that. So I've mentioned this to a couple of people. Yes, we've done a series of podcasts on the show about machine learning infrastructure, and I've been writing ebooks about machine learning infrastructure. And it's a space that I'm really excited about. And I've looked at TFX in the past, and it was hard to really like wrap my head around it. It's just like this kind of random collection of tools.
Yeah.
But what was announced yesterday seemed like the beginning of making it more coherent. And kind of like when you read the TFX, like the papers, like it's clear that Google has this kind of very elaborate, sophisticated infrastructure internally. And I think looking at that and then seeing what was previously available made it even more disappointing. It's like, that's all you're giving me is like
data validation and serving. Like,
yeah. So maybe kind of what's your, what's the kind of the top line on TFX, or what are you excited about from that perspective?
I'm so glad that you mentioned TFX, because TFX is one of the reasons why I wanted to come work at Google in the first place. Like, I read the paper. And I think I mentioned a little bit before, I worked as a data scientist in the energy industry for a long time. And the hard bit, like it was always delightful to create the models. It was cool to have this like crunchy engineering challenge and to take data and to figure out how to solve it in a way that sort of made sense and that would be performant and explainable. But then the hard part was always, okay, cool. Now, how do I deploy it? Like, how do I get it placed? How do I have this model placed into a format that somebody can use in a software application? And then once it's released, how do I make sure that it's doing its job and that it's kept up to date? And how do I make sure that the incoming data stays consistent with the data that was used to train the model initially? And if I want to do online training, how would I go about doing that? Mm-hmm. So all of these like really interesting questions where the model was just like this tiny piece of this big overall like sort of continuous integration, continuous deployment strategy, like DevOps for data science. And and TFX, the paper, sort of gave it sort of elaborated on a strategy that Google's been using successfully over the past 10 years to do that effectively. Because most businesses, they create custom glue code. They don't really, they might have a component of DevOps for their machine learning models, but a lot of it might be manual. So not necessarily, an example would be if your model falls below a given accuracy for a stint of time, how is your
somebody?
yeah, like, or it's like, and if you're the other piece, right, is that data scientists, they're probably creating their model in Python or R. In order to get it integrated with a software application, that model, at least where I worked previously, it would have to be refactored into something like Java or C++, which means that usually your accuracy goes down. Like it's not a good situation. And then if your model needs to be updated, how are you going to take that C++ and Java, give it back to your data science team and be like, well, fix it now? There's no straightforward path to do that. With TensorFlow, it's the same framework for everything. So the data scientist can create it. It can be deployed by your DevOps team. It can be maintained by them as well. And then if it needs to be modified, it's the same TensorFlow code that your data scientists know how to use. So TFX, you're right, in that when it was announced last year, they only had like two little components of this sort of toolbox of things. Everything from data validation, which allows you to do those data checks that I was mentioning before. Transformation, so TFT, TensorFlow Transform, which allows you to do pre-processing on data pipelines to make sure that, and full pass data processing, to make sure that your statistical distributions for each feature are similar as they're coming through your pipeline. Model analysis, which gives you insight into how your model's performing over time. There's even a GUI to show you sort of metrics associated with that. Of course, there's serving. And then there's also sort of additional tools that I believe Clemens mentioned yesterday, a collaboration with Kubeflow, but all of these sort of products that bundled up together alleviate the need for you and your company to have to write glue code and to have to refactor models, and it gives you the tools to deploy models in a maintainable way.
Yeah, there's also an interesting bit in there about kind of a metadata repository where you're able to track all of the configs and parameters associated with various both
data lineage
experiment
and data provenance
runs, right? So you have your experiments, and then when you have a model that you're pushing out to production, all that information. And there were some use cases presented, to your point, that shows how you can use that information to go kind of work backward from a model decision to what training data, impacted that model decision, and what the experiments were that kind of drove to those sets of model parameters and stuff.
Absolutely. And that's huge in terms of model explainability. So if you're working in a high impact industry, again, like the oil industry, you had to be able to explain why you made a decision just in case it was the wrong one. And then also reproducibility. So if somebody wants to take your results and try to replicate them on their own data, or try a different model and see if the performance varies, then having all of that metadata associated with the input is huge.
Anything else that we've not talked about yet that you left excited about yesterday, or you knew about it already, but
but it was still exciting to hear. So I'm really. It's not a secret. Like I am most excited about the community focus for TensorFlow, and I really love that 2.0 has been pushing for community involvement and like not making any changes unless everybody who's using the tool is is informed and has had the opportunity to give feedback. So the original release of TensorFlow felt very much like delivering tablets down from a mountain, kind of almost. It's, the code was released, and over time, like, community could get involved, but it was really only through this thing called Contrib. And for the most part, the engineering was done by the engineering team at Google. And since then, it's developed into more of a partnership between individuals in the community, but also companies who are using TensorFlow extensively, and students, or application developers, or not just deep learning researchers, but really people coming from all walks of life who want to incorporate machine learning into their tools, who have crunchy problems. that machine learning can help solve. So that is my favorite thing, is that TensorFlow 2.0 is all about community.
You mentioned the RFC
Yes.
process, and that's a new process since.
The RFC process is a new process that was begun, I believe, halfway through last year.
Okay.
So maybe July, August of last year.
Okay.
And again, if you want to make a change to the API, anybody can do it. So if you have an idea that you think would be solid, you just propose it. The engineering team, both at Google and then also externally, reviews it, delivers commentary. And if everybody agrees, then development work can start.
Awesome. Well, Paige, thanks so much for taking the time to chat with me.
Thank you so much for having me. This was fun.
Absolutely. Absolutely. Thank you.
All right, everyone, that's our show for today. For more information on Paige or any of the topics covered in this episode, visit twimlai.com/talk/242. Thanks again to the TensorFlow team for their sponsorship of this series. Make sure you check out the TensorFlow 2.0 alpha at tensorflow.org and enter our TensorFlow Edge giveaway at twimlai.com/tfgiveaway. As always, thanks so much for listening, and catch you next time.